Vectors. Intersection of three planes made simple by Anil Kumar. We'll discuss Gaussian Elimination Method and understand the type of intersection between these three planes. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are discussing IB test question which is based on intersection of planes in vectors. The question here is, three planes are described by the following equations. Write solution and describe the geometric relationship between the planes. You can always pause the video, answer the question, and then look into my suggestions. Those of you who want to learn directly from us, send an email on globalmathinstitute@gmail.com. Our students have been extremely successful. We take up real test questions which make huge difference, and we also discuss alternate methods of solving them. Now, system of equations, three of them, we could use matrices to solve it. In this particular video, however, I will show you Gaussian elimination method to provide the complete solution of this question. So there are two things here. One is write solution, and the second one is describe the geometric relationship between the planes. The reason why I'm not using matrices is answering the second part. The beauty is to use the Gaussian method and then show you, right? So it is more meaningful in the context. So let us also understand the Gaussian method as we move along. We are given three equations which are 2x plus 4y plus 3z equals to 20, x minus 5y minus 2z equals to minus 11, x plus 11y plus 6z equals to 37. Now, first step, which most of the time is overlooked, is rearrange these equations. Now, I call this step as one of the most critical steps. See, if you rearrange, you can simplify the question to a very large extent, and you're always working with a very beautiful numbers. So what I will do here is that the second equation, I'll put it first. So I'll rewrite these equations. So these three set of equations I'm rewriting as x minus 5y minus 2x equals to minus 11 as my first equation. Second equation and the third equation we could, interchange. So I'll write the second equation as x plus 11y plus 6z, that is 2z, right? I wrote x. 6z equals to 37. And the last equation I'm putting as 2x plus 4y plus 3z equals to 20. Now, in these equations, we could actually write them in augmented matrix form. So in Gaussian method, we prefer to write them in augmented matrix form since the operations performed are really based on the coefficients, right? So this is the augmented matrix. So 1 minus 5 minus 2 minus 11 1 11 6 37 and 2 4 3 20. Correct. So the first equation I have written at the end. So that becomes the augmented matrix. Now let us see how do we solve from here. The idea is to get zeros in these three areas. That is the idea. So, to get a 0 in the positions on the corners, the first column, what we are going to do is we are going to rewrite these augmented matrix as I will subtract from R2, row 2, I'll subtract row 1. So I'll get a 0 here. And here I will subtract from row 3 2 times R1. Is that okay? So R1 will not change. It will be 1 minus 5 minus 2 minus 11. As far as the second row is concerned, since we are subtracting the first row from the second, we get 1 minus 1 is 0. So that was the idea, right? 11 minus 5 will give us 16. 6 minus minus 2 gives us 8. And 37 minus minus 11 gives us 48. And in the third row, from 2, we subtract 2 times 1, which gives us 0. That is what we wanted. And from 4, we are going to subtract 2 times minus 5. So that means 14, 4 plus 10. And here, 3 minus 2 times minus 2 means 3 plus 4, 7. 20 minus 2 times 11 is 22, so 42, right? So we get the augmented matrix. Now, what you should do from here is simplify each row. You can see that the second and the third row have a common factor. So they can be now written as, let's rewrite. So we'll maintain the first as such, 1 minus 5 minus 2 minus 11, correct? You can divide this by 8, right? So 0, 8 goes 2 times, 8 goes 1 times, and 8 goes 6, 8, 48. 6 I have to write, right? 6. The last one I could divide by 7, so I get 0, 2, 1, 6. Is that clear to you? Now what do you notice? You notice that row 2 and row 3 are exactly same, right? So if I do row 3 minus row 2, what do I get? What I get is first being same, second we'll just keep it as such. We're not doing anything to that, but in the third row we are subtracting the first, so I get 0, 0, 0, 0. You see that? So we get 0 equals to 0. Now that makes sense, right? 0 is equal to 0. So now we can answer the part which is describe geometric relationship between the planes. Can you tell me, if we get this 0 equals to 0, what is the geometric significance? Well, definitely, we have infinite solutions, right? Now, infinite solutions really means what here? Is a line. Do you understand? These three planes intersect in a line, like a book, you see. So, in a book, we have many pages, and they all intersect along their seam. So, that's the line. So, it's like a book. So, that is the geometric significance of this particular thing. So, which you could actually show in a way like this. So, we have one plane here. Let's call this as plane 1. Correct. And then we have another plane which is intersecting this. Okay, so we got two planes, and the third plane is also intersecting in the same line. Do you see that? Do you see that? So we have a line of intersection between the three planes, correct? Makes sense, right? So that is the geometric significance which we were talking about. I hope the steps are absolutely clear. Right. Now let's move on to the second part, and that is to find the solution. What can be the solution? Or that is to say, what is the equation of line which is going to satisfy? Okay. So what we get here is we get a parameter here, right? So we write a parameter, and let's say parameter will be parameter in this particular case is going to be, let's say z is equal to, let's say, some k, right? Some constant k. So z could be any parameter k. Now from the second equation we have 0 to 1 6. Let's rewrite in the form of an equation. We get 2, so y plus z equals to 6, right? So where we know z is k, right? So we get 2y plus k equals to 6. Correct. So we get 2y in terms of 6 minus k. Now, in the first equation, what do we have? We have, let's change the ink. In the first equation, we have x minus 5y minus 2z equals to minus 11. Now, in this equation, I can substitute the value of 2y and get the solution, right? So let's take it on a new page now, correct? So let me begin the solution in a new page, writing the three equations. So let's rewrite these equations. So we rearranged, and so we had a solution. Let's write down the matrix now first. So first equation was 1 minus 5 minus 2 minus 11. It didn't get changed. Here we had 0, 0, 0, and here we had 0. Let's rewrite, see that equation, correct? 216, right? Correct. And we are saying we have one parametric equation which is z equals to k. And then when we substitute it, 2y plus z equals to 6. So from here we get 2y equals to 6 minus k, right? So okay, let me rewrite. So we have z equals to k, and we also have, let's write y equals to 6 divided by 2, which is 3 minus k by 2. Makes sense? Let's look into the first equation, which is x minus 5y minus 2z equals to minus 11. Substituting, we get x minus 5 times 3 minus k by 2, correct? And 2k equals to minus 11. So x is what? So x will be equal to, taking all these terms to the right hand side, we get 5 times 3 minus k by 2 plus 2k minus 11. So x is equal to 15 minus 5k by 2 plus 2k minus 11. X is equal to 15 minus 11 is 4, right? And combining these terms, we get 5k minus 4k minus k by 2, right? Minus k by 2. So we get x as 4 minus k by 2, right? Okay. So we have our solution now, which is x equals to 4 minus k by 2. Y equals to 3 minus k by 2. And z equals to k. So that is the solution. So the equation of line is what? Equation of line is, we have a point here which is 430, plus we have k common, so we can write minus k by 2. Let's rewrite this, right? Minus k by 2. Y is also minus k by 2 and k, correct? So we could rewrite this as 432, 430 plus some lambda. Lambda equals to k by 2 for us, okay? K by 2. We are factoring out k by 2 from here. In fact, minus k by 2 will factor. So we get 1, 1 and 2. Do you see that? So that becomes the solution for the given equation in this particular case, right? So we factored minus k by 2. So we get 1, 1. Since it was minus k by 2, it will be minus 2 here, right? So minus 2. Okay, so let me show the step in a different ink here, just to be, we need more space, that is all. Okay, so I'm showing the step here. So we said line R will be the coordinate point 430 plus, we are taking minus k by 2 common, right? So let's write down minus k by 2. So inside we'll have 1, 1 and minus 2. Is that clear? Now, minus k by 2 is also constant. So we can write this equation of line as equal to 430 plus lambda, where lambda belongs to real numbers, 1, 1 minus 2. Is that okay? Lambda belongs to set of real numbers. Makes sense? So that is how we can find the equation of line moving forward. Perfect. So as you can see, Gaussian elimination method actually helps us to understand and visualize the situation. Extremely good and simple method to apply. I hope it makes sense. Feel free to write your comment, share your suggestions. In case you like and subscribe to my videos, that'd be great. In case you want to learn from me, send an email to globalmathinstitute@gmail.com. Thanks for your time and all the best. A request from Anil Kumar. Feel free to support our channel whenever possible. Thank you and all the best.